Good evening, my name is Eric Nathaniel as your news anchor for today. Welcome to your DM Engineering News Special Report. Malaysia received more than 2,500 mm of rainfall every year as our city continues to expand. Roads, parking lots and pavement are increasingly covered with conventional concrete. Although conventional concrete is strong and durable, it creates one major problem, which is rainwater cannot penetrate the surface. Instead, water rushes into drains, increasing surface runoff, causing flash flood, overwhelming drainage system, and reducing groundwater recharge. Could one innovative engineering material help solve these problems? Today, our team investigate the science behind permeable concrete. We now go live to our field reporter.
Thank you, studio. My name is Farah Anwar and I report live from the field. Here you can see a typical concrete pavement commonly found in the residential and commercial developments.
During rainfall, conventional concrete pavements generally prevent water from infiltrating into the ground. Instead, rainwater flows across the surface and into nearby drains, which increase the surface runoff.
To overcome this issue, engineers have developed an alternative known as permeable concrete. Right here are two types of concrete techniques. One is conventional concrete and the other is permeable concrete. Now let's test how these two types of concrete perform under the same rainwater condition.
As you can see, for the conventional concrete, the water remains on the surface and does not pass through the concrete. Meanwhile, for the permeable concrete, the water quickly passes through the interconnected pores within the concrete and drains through the specimen.
This simple demonstration clearly shows the difference between the two materials. While conventional concrete blocks the water from passing through, permeable concrete allows water to infiltrate, helping to reduce surface runoff and improve stormwater management. But how does permeable concrete achieve this while still functioning as a pavement? Let's hand it to our engineer material analyst.
Thank you, Tara. I'm Izan Omar, an engineering material analyst. Permeable concrete is an engineered material specifically designed to allow water to pass through it while still supporting structural loops. The engineering performance of permeable concrete depends on several key properties. First, the work ratio ranges from 50 to 30%. Second, the permeability ranges from 2 to 18 mm per second. Third, the density typically ranges between 1,600 and 2,000 km per cubic meter. Fourth, the compressive strength ranges from 3.5 to 38 megapascal. Relationship between properties. When the ratio increases, more interconnected pores are formed within the concrete. This allows water to flow more easily through the material, resulting in higher permeability. However, increasing the amount of void space reduces the solid concrete structure and lower its compressive strength. Therefore, engineers must carefully optimize the void ratio to achieve the balance between permeability and strength. Engineering principle. This relationship is explained using Darcy's law, which describes how fluid moves through porous materials. Engineers use this principle to design permeable concrete systems that provide effective stormwater management. Permeable concrete is commonly used in parking lots, sidewalks, driveway, and cycle lanes. These areas generally experience low traffic loads while requiring efficient stormwater drainage. Beyond drainage, this material also introduces several engineering innovations. First, stormwater management. Rainwater flows through the pavement instead of across the surface. Second, groundwater recharge. Water naturally replenishes underground aquifers. Third, urban heat reduction. Evaporation from stormwater helps lower pavement temperatures. Finally, natural filtration. The aggregate and soil layers help remove sediment and pollutant before water reaches groundwater. Let's now examine how this innovation benefits society and the environment.
Thank you, Izzat. I am Muhammad Adakar Ibn Faisal, an environmental correspondent to the case. Our investigation found that permeable concrete provides significant benefits to society. First, permeable concrete reduces the flash floods. Second, it also makes less water ponding. The third one, it also makes a better groundwater supply. And lastly, permeable concrete also provides a safer road. Environmentally, permeable concrete contributes to sustainable urban development. There are also benefits to environmental, which is reduces urban heat, improves stormwater quality, supports sustainable drainage systems, and also it reduces environmental impact. These advantages directly support sustainable development goal SDG 9, which promotes resilient infrastructure and sustainable industrial innovation. However, no engineering material is perfect. There are also disadvantages and challenges. The disadvantages of using permeable concrete is it causes clogging, low in strength, high construction costs, and also need a regular maintenance. Fortunately, engineers have developed several effective solutions to overcome the challenges. First is vacuum sweeping to remove dirt from the pores, proper maintenance schedule, fiber reinforcement, better mesh design to provide a balance between strength and water permeability, and also a better scale construction. To learn how these improvements are implemented in practice, we interviewed a site engineer.
Hi, today I'm going to interview an engineering consultant. Hi, can you introduce yourself?
Hi, my name is Lokman Hakim and I am engineering consultant.
Okay, based on your experience, why is permeable concrete becoming increasingly popular?
Okay, so from my experience, permeable concrete become popular because modern city requiring sustainable solutions that address both engineering, performance and environmental protection. So permeable concrete reduce stormwater runoff while improving groundwater recharge. Although its initial cost may be higher than conventional concrete, lower drainage requirement and environmental benefits often make it economical over its service life.
Would you recommend this material?
Yes, it's for parking lots, sidewalks, parks and residential developments. Permeable concrete is an excellent sustainable engineering solution.
Thank you for your cooperation, sir.
Thank you to our team for that informative report. Throughout this investigation, we used reliable sources including engineering journals, international standard government publication, and industry practices to ensure accurate findings. Our investigation showed that permeable concrete is innovative material that reduces surface runoff, support groundwater recharge, and promote sustainable urban development. While it has some limitations, such as low compressive strength and maintenance requirements, this challenge can be managed through proper design, construction, and maintenance. As city growth and climate challenge increase, permeable concrete will continue to play an important role in creating sustainable and resilient infrastructure. This has been the UiTM Engineering News Special Report. Thank you for watching and see you in our next report.